This is the solution video for problem set 8, problem 3, and I'm just going to solve it right on the problem definition. And here we're given 3-bit registers and a quad 2-to-1 multiplexer, and we're told to need to implement the following 4 conditional register transfers. And so when I look at this, what do I want to pay attention to? Well, I want to pay attention since I'm only 2 of my muxes, 2 of my registers are going into the mux. I need to be careful about which 2 I select are going to go into here. And then on top of that, I need to figure out how I'm going to connect one of these registers to another one of these different registers without the mux. And so this is going to be a little bit hard. So basically, I'm going to look at what's going in and what's coming out of each register to figure this part out. So here I notice that R1 is going to R3 and R2. And I also see that R2 needs to go into R3. So based on this right here, these are the ones that are going to go into the mux. Because R2 and R1 need to go into the same register. Whereas R3 is going to R1 and nothing else is going into R1. And so that's all I need. That's how I figure out this first part, is by doing that. So I'm going to connect R1 to there and R2 to there. And then this needs to go to at least to R3. The next thing I need to figure out is where's R1. How do I want to do R1 into R2? I actually have 2 options here. One is to put R1 in, just do this and put that into here. Or another equally viable option is just to put R1 directly into R2, because I don't have to compete for that. And same thing with R3 into R1. I'm not competing for an input into R1. And so that completes everything for that part. And now I just need to figure out my select bit, and I need to figure out R3 into R1 and R1 into R2. So I need to figure out when these get loaded, and I need to figure out this. So my mux, basically I want to choose between R1 and R2, and basically I'm going to choose R2 when K2 is 0. I'm going to choose R1 when K2 is 1. Simple enough, I'd say. So R1 is here, is going into 0, so I need K2 bar to get 0. And then when this is 0, this is going to get me 1, so that's done. R1 gets loaded only for K1 bar K3. And then R3 gets loaded for, so this is K2 or K2 bar K3, which is just K2 or K3. So R2 gets loaded on K2 or K3. And then this is K1, K3 bar, and that's, oh, oops, this is K2, wrote this on the wrong one. And this one is K1, K3 bar. And this is an AND. So K1 and K3 bar. And that completes part 1. And then part 2 is very similar. We're going to do this, except we have a single bus. And so basically we need to figure out which set of instructions is going to cause a conflict. And so basically what I'm going to do is I'm going to actually kind of draw a weird truth table, I think. Notice I think it's a weird truth table. So K3, let me do K1, K2, K3, because that's going to match how I find the conflict. So 0, 0, 0, 0, 0, 1, 0, 1, 0. Sorry, you probably don't need to listen to me say all of that. And basically I'm going to put a dot whenever R3, R2, and R1 want to get onto these buses. And so this is for 0, 0, 0, K1, none of them are going to go onto this because all of them have a 1 at some point. And then 0, 0, 1, so this is satisfied for 0, 0, 1, and this is satisfied. So R3 and R2 want to be on the bus. And R1 doesn't want to be on the bus during that time. Then we got 0, 1, 0. So this can be on the bus at that point. And that's it. So only R1 can be on the bus here. And then we've got K2, 0, 1, 1. So this can be on the bus at that point, as can this. So this one says I want R1 and R3 on the bus at a time. I've got 1, 0, 0, so that is going to be, this one can be on the bus, and that's it, I believe. So this is R1, can be on the bus. And then we've got 1, 0, 1, so I'm going to put a dividing line here just to make it a little easier to see. 1, 0, 1, this one won't be on, this one can be on, this one can't be on, this one can't be on, so this is just going to be R2. And then we got 1, 1, 0, so 1, 1, 0, this can be on, this can't be, this can't be, this can be, but these are both R1, so that's not a problem. And then 1, 1, 1, these two can't both be on, this can be on, so this is R1 is on the bus. So we have conflict here, and conflict here. So K1, K2, so 0, 0, 1, or 0, 1, 1 would cause a conflict. And so what we want to figure out is what two commands were on here. So we had R3 into R1 and R2 into R3. And this one had R3 into R1, 0, 1, 1, and R1, so 0, 1, 1 would be this one, and R3 into R1. So both of these have this in common, so we want to eliminate R3 into R1. So if you eliminate this, there's not a conflict here, there's not a conflict here. So that eliminates these, and so now we basically just implement this. So we want to put R1 onto the bus, pretty much when K3, so K1, K3 bar, or K2. So this one is K1, K3 bar, or K2. And this, you want to put R2 onto the bus when we have K2 bar K3, and you'll never want R3 on the bus. And then we've got, what comes up next? Loads. We want to figure out when we load these, so we load R3. And both of these, so this is K2 and K2 or K2 bar K3, so this is K2 or K3. We aren't, and we do, this is K1, K3 bar, and we don't ever load R1. And that completes problem 3.